So system grounding is a part of a building system that provides protection against electrical shock, lightning, and fires. So, mo siya figure below sa right side. So since nana siya kuan ground, so grounding of an electrical branch circuit enables current to take path or to take path back to the overcurrent protection devices. So that's why naay cases na ma-short circuit ang usa ka device or appliances. So automatically siya mag-shutdown ang circuit sa device. So safe siya. Best way nga example ani kay katong kuan. Ground fault happens before the load ug after the load. Ay before the load ug after the load. Next ko curves. And we have a grounding system must be connected to some or all of the following elements if available on the building premises. So an underground metal water pipe in direct contact with the earth for no less than 10 feet. The metal building frame where it is effectively grounded. An electrode made of at least 20 feet of electrically conductive steel reinforcing bars or bare copper wire no smaller than number 2 AWG that in in case in at least 2 inches of concrete that is part of the foundation of footing in direct contact with the earth. And next, an electrode made of steel or iron plate that is at least 1/4 thick of copper plate that is at least of 0.0 inches thick with at least 2 feet squared of the plate of surface in contact with exterior soil. Now, next is an electrode made of grounding of bare copper wires no smaller than 2 AWG encircles that building depth or no less than 2.5 feet below grade. So the structural metal frame of building where the frame is effectively grounded. Okay, next ka curves. So moving on to equipment grounding. So equipment grounding refers to a grounding conductor or grounding path that connects the non-current carrying metals components of equipment. So equipment grounding can be identified as bare conductor or green colored. So kaning nasa right side naka-attach siya sa metal housing or sa cabinet kaning green. So moving on, so equipment grounding and system grounding electrode must be bounded. Bonding is accomplished by installing an additional grounding conductor or permanently joining metal components in circuit. When joining components to form a good bond, special connection called bonding jumpers may be required to ensure a good connection between the metal components. Bonding jumpers are required in instance when flexible conduit is used. Next slide. And we have a tables available in code indicate the minimum size of equipment grounding conductors for grounding raceways and equipment. They are used to size equipment grounding conductor. So equipment grounding conductor should be in the same raceway or cable or as the circuit conductors. And lastly, double insulation. Double insulation of an appliances or power tool protects the user from the electric shock by creating a non-conducting barrier between the user and electric component inside the appliances or tool. So it's a non-metal casing, so dili siya mag-require of earthwire. And double insulation provides two levels of insulation. So first, the electric cable is insulated from the internal components of the appliances. Secondly, the internal components are insulated from the external casing. So that's mean So pasabot ani is kung mag-fail ang first nga ang insulation, ang second insulation ang musalo, so mag-provide siya og protection. Mao ra to. Thank you. Proceed kay kuan, Maureen Tikson ug kay Mary. Thank you.
So, madunggan ako, guys.
Oh, madunggan na.
Okay, thank you. So, good evening, everyone. I'm Marine Dixon. Ay, sorry kay gitawag ko sa akong tatay. So, continue. Good evening, everyone. I'm Marine Texon, and my topic is the building electrical system. So, proceed na ta. Electrical systems form a very important part of any building. The purpose of it is to distribute the power safely to all the curbs kanang paki next slide ko please. Okay, thank you. So, sa lagay tagali. So, kaning koan the, the purpose of electrical system is to distribute the power safely to all the different rooms and appliances. They are needed para mag-operate ang atong heaters, fans, and elevators. There are many possible electrical systems that can be used to distribute power in a building. So typically, system design begins with selection of a building system voltage, which is dependent on sizes and types of the connected loads, utilities near the building, local codes and ordinances, economics, and safety. So it is said that it is more economical to distribute power at high voltage because it is more efficient than a lower voltage, since it experiences less energy loss from resistance. Sama sa gingon ni and higher voltage mean lower amperage, which allows use of smaller conductors. So, and then use of high voltage, however, introduces more complex safety issues, and so use of high voltage in buildings is reserved for equipment with heavy loads. And then larger installations have greater power requirements and thus require higher building system voltage. So basically, kaning large installations ka industrial system, while smaller installations, such as residents, use lower voltage systems to avoid exposing occupants to safety issues related to higher voltage. So next, please. There are typical types of building electrical systems, and these are introduced in the following. So, kani sila kay residential systems, multifamily dwellings, commercial or industrial systems. Next slide, please. So, the first one is residential systems. Next slide. So, makita to sa picture guys nga kanang muna siya ang power distribution in small buildings or residential buildings. So, as we can see, residential buildings have a very simple power distribution system. And katong gagamit og cellphone, pwede rin nyo i-zoom para makita gyud siya guys. And then, ato nang i-discuss ang unsa kanang ang power distribution nila. Og ang una ani kay the utility will own the transformer and the transformer reduces the voltage from 13.8 kilovolt down to 120 over 240 or 120 over 208 volts and then passes the electricity to a meter. So after sa meter, the power is transmitted into the building at which point all wiring, panels, and devices are the property of the building owner. Wires transfer the electricity from the meter to a panel board which is located in the basement. So makita na sa picture nga ang panel kay located dito sa basement, no? And then the panel board will have a main service breaker and a series of circuit breakers which control the flow of power to various circuits in the buildings. And then each branch circuit will serve a device or a number of devices like convenience outlets. And then power from a ground or pole mounted utility transformer located outside the building is brought to the building service equipment through underground or overhead service entrance lines. So next please. So the first picture shows the underground electrical distribution lines serving a residential development being buried in a trench. And then the second picture shows the underground distribution lines needed for connection to exterior transformer. So if you are wondering kanang asa ni commonly used ang kaning underground wiring system, so kani ang answer. Underground cables are usually used in such locations in urban areas where local or state regulations override economic considerations such as airports. So, ginagamit or so kanang kaning underground wiring system kay makita nato sa airports where an overhead line may endanger lives. So, next slide please. Thank you. And in large residents, a set of feeders may extend from the main panel board and bring power to one or more sub-panel boards located at a remote area of the building. Branch circuits originating at the sub-panel board feed outlets in these outlying areas. Next slide, please. So the second type is the multi-family dwellings. So ang example ani kay apartments and condominiums. Next, please. So, in multi-family dwelling units, power is brought from a utility transformer to the building service equipment. It is then divided at the main distribution panel, passes through individual meters, and is distributed to the individual dwelling units through feeders. Each dwelling unit is served by a separate panel board located in the dwelling unit. Branch circuits extend from a panel board to feed outlets within the unit. A house panel board has branch circuits that serve common areas like corridors, laundry rooms, and lobbies. So for the conclusion of my topic, the designs of the electrical systems vary from one building to another, depending on the design and purpose of the building and the components within the building. An industrial building, which is ang next type, differs from both residential and business building because their electrical power requirements vary. And to avoid confusion, the sizing of branch circuits, feeders, and service conductors for multi-family dwellings is similar to the sizing for residential systems. We just size the feeders to individual dwellings units in the same manner. And also to add another information, apartment unit electrical power is distributed at 120 over 208 volts, three-phase, four-wire to maintain utility metering. So that's all for my topic. Thank you for listening. Miss Tao will report the commercial industrial system. So thank you. God bless.
Next slide, please. Commercial and industrial systems. Commercial and industrial centers are built for businesses. Examples of commercial buildings are restaurants, shopping centers, retail stores, and hubs of entertainment, and many more. While industrial buildings are centers for manufacturing goods or products for businesses. Next slide. Large commercial and industrial facilities have large and varied power requirements that necessitate different types of systems for different building occupancies. Essentially, there are so many variations that there is no standard type of system. Next slide. So, in a typical large building, electrical power is provided to a transformer located outside the building, or it enters a transformer vault located at the service level in the building. So a transformer vault is a basement or ground level structure or room in which power transformers, network protectors, voltage regulators, circuit breakers, meters, and so on are housed. Commercial and industrial facilities usually contributes to more efficient and consistent supply of power. Three-phase power normally enters the building with three ungrounded hot conductor lines sharing a common neutral conductor. A transformer steps down power to voltages below 600 volts at the step-down level. At the step-down level, the electrical power passes out of the transformer to the main switchboard serving the building. So, example sa switchboard is kaning nasa left side nga picture. So, the switchboard is located in a separate room near the transformer or adjacent to the transformer vault. At the switchboard, power passes through meters and circuit breakers or fuses as it is divided into primary circuits and is then carried by feeder busways or sets of large conductors into the different parts of the building. Next slide, please. So, including the switchboard, these are other commercial and industrial and their function, industrial systems and their functions. So first is the service entrance conductors and di kayo na ako maklaro. Pwede ma-zoom kung gamay. Wait. Sige.
Hindi siya ma-zoom.
Sige. Era. So, first photo is showing service entrance conductors and
Bella Merida. Klaro na ko dali. Okay na?
mag-open na lang sa ko kuan.
Ako na yung basahon ng tulo ko po. So the first picture, which is the photo 19.24, says that service entrance conductors and feeder conductors encased in...
Nara di ay nakuha na nakaroon na. Kaya ako na. Sorry po. So first photo is showing service entrance conductors and feeder conductors enclosed in conduit and wire gutter. So, nasad ang kuan diha grounding wire kanang sa baba. So kaning ang conductors, ang service entrance conductors is gi-enclose siya sa isa ka conduit. Kaning conduit nga ang conduit diri is mao ni siya ang kaning murag tubo kaning sa ibabaw din. Kaning sa baba mao ni siya ang wire gutter. Grounding wire. Sorry po. So, next photo, makita na to closely ang ground wire. So, ground wire connection to grounding rod that extends into earth on other side of foundation wall. So, through sa service entrance conductors, kanang nag-transmit na siya og kanang electrical power sa kanang transformer volt, and then ang at the step down level ang transformer mag-distribute og power sa kanang sa switchboard and then sa distribution panels. So kaning ikatulong nga photo is our distribution panels with fuse disconnects. So ang next photo is nag-show siya sa kanang sulod sa distribution panel and kanang gipakita diri ang kanang two sets of fuses. And pag i-close nimo sa next photo, makita nato ang kanang fuse disconnect, which is kaning murag switch good nga mag-on ug off sa kanang ay mag-on off ay mag-shutdown sa kanang mag-shutdown sa circuit. Then sa next photo is next photo is open distribution panel with 3 cartridge fuses protecting a 3-phase feeder. So ang fuse diri is kaning tulo ka buok. And ang kanang use of fuse is para kanang mao na siya ang material para material meant to melt or sacrifice itself in the event of an overcurrent event. And sa next slide, please. So, first photo is showing a 3-phase panel board providing, wait lang. So first photo is nag-show o kanang 3-phase panel board providing 3-phase power to equipment such as milling machines, di kayo na ako maklaro. Kadali lang po. Wait lang po. Ako sang i-open sa ako ang kuan na makoy medyo maklear. So, example ay ang mga equipment nga examples is milling machines, machining centers, and so on. So, kaning maghatag sa og power ang panel board sa single ay kaning maghatag sad ang panel board og single phase power for lighting kaning 277 volts. And next sa photo kaning next photo is 3 feeders from the main distribution panel connected to lugs in the panel board. So the lugs connect to the 3 bus bars to which circuit breakers are connected. The fourth conductor kaning nasa left side nga kaning diba na itulo diri at tapos sa baba mo ni siya ang kuan fourth conductor nga kanang gi-describe diri as kaning sa left. So, in the grounding sorry po. The fourth conductor in the grounding conductor which connects the panel board ground to main distribution panel near the service entrance. Then below is inside the panel board with kanang showing the circuit breakers nag-install. Then close up dayon. Next is the close up nga kanang close up photo para mas maklaro ang kuan ang sulod sa circuit breakers ay kanang maklaro ang circuit breakers. So kani is a close up view of the 3 bus bars. Then an individual 3-phase wait lang, hindi na pa ako maklaro. An individual 3-phase breaker protects 3 conductors on 3-phase circuit. So, kaning breakers. Kaning kuan mga breaker is kanang safety device gihapon siya para mag-protect sa electrical circuits from damage caused by overcurrent, overload, or short circuit gihapon. Next is kanang conductors for each circuit extend through conduits from the main panel board. So kanang ang panel board is kanang Dadto nag-connect ang mga conduits para ay, conductors for each circuit extends through conduits from the main panel board. So, ano kanang in the kuan kana siya kanang sa first photo aning sa right side. Then kaning through sa kuan through sa conductors through ay kanang conductor is connected ayon sa kanang equipment kaning mga switches and controlled by heavy kaning mga circuits to equipment are controlled by heavy duty switches. Then kaning mga cable is ginasulod gid sa kanang murag kanang ginasulod sila o kanang sorry po. Kay para dili gud siya sa mga kuan commercial o industrial nga daghan gud na sila wire mo nang kuan nila gina-enclose nila sa isa ka sudlanan. And then
Okay, sir. Excuse me.
Josephine, asa ka sudlanan yung pasabot ani sa picture?
kani sa sorry po sa right side then sa ikatulong nga photo sa photo 19.37.
Kaning 19.37.
Yes po, sorry kayo, sir.
Di pa dayon.
Then, kaning mga armored cable dayon is kanang connected sa kanang mga na-connect siya sa mga gi-connect siya sa mga electrical boxes receiving conductor carrying kaning electrical boxes receiving conductor carrying armored cable. Para kaning electrical boxes kay muna ni siya ang para easy na ma-access ang electricity. So, para magamit ng electricity. Sorry po. Mara po. Next. Wala na.
So I guess that would be all for building electrical system. So let's proceed with the conductor requirements. So supposedly Mr. Ryan Mugot should be the one reporting this topic, but his internet connection says otherwise. So ako na lang on his behalf. So conductor materials. Copper and aluminum are the most common conductor materials used in building electrical wiring, although other materials can be used. As a general rule, solid copper conductors are used in small conductor sizes or up to about 8 AWAG. So stranded aluminum conductors are widely used in larger or above 30 amp circuits serving large motors, equipments, and appliances such as clothes dryers, kitchen ranges, or central air conditioners. So the uses of UL listed 15 amps and 20 amp switches, outlets, and other devices marked CO/ALR is presently accepted. So CO/ALR means copper aluminum revised. So these means that the device is suitable for the use of aluminum wirings. So since I discussed naman tong UL ganyan, which is ang meaning ana is Underwriters Laboratory. Sila ang laboratory na nagakuha ng safety standards requirements sa mga wirings. So proceeding. So this table shows the different conductor sizes with their corresponding uses. So as you can see, na ay number 20 AWG, 16 to 18 AWG, ang ilan na mga uses. So dili na kayo kung mag-go deeper na. So next is the conductor insulation. So conductors are covered with insulation to provide electrical isolation and physical protection of the conductor material. Wires used indoors are subjected to less exposure to the elements than those designed for outdoor use. So outdoor wiring on the other hand, is exposed to water and sunlight. So the insulation is designed to withstand these elements. So mag-vary ang insulation type sa use sa wiring systems. So conductor ampacity requirement. Heat generated at the equipment terminals can damage the conductors if it is not used properly dissipated. Unless equipment terminals are marked otherwise, circuit conductors are to be sized according to the 100 to 140 degrees Fahrenheit or equivalent to 60 degrees Celsius for equipment rated 100 amps and less. And equipment rated over 100 amps must be sized to 167 degrees Fahrenheit or equivalent to 75 degrees Celsius. So next is the temperature correction factor, or the F sub T. It is applied based on the ambient temperature of the conductor. So the ambient temperature is the temperature of a surrounding medium, for example, air or soil. The ambient temperature can affect allowable current carrying capacity of a conductor. As a ambient temperature rises, less current generated heat is needed to reach the temperature rating of the insulation. So the ambient temperature rating of a conductor refers to the normal temperature range in the environment in which that conductor is to be used. The temperature of the surrounding air, water, or earth, muna sila ang ambient temperature rating. The bundling correction factor. It must be applied for 4 or more conductors in a raceway or cable installed in the same raceway or conduit, or any bundled cables that are more than 24 inches or 0.63 meters long. So take note that these factors are applied such that the ampacity of a conductor at a specifically operating temperature is the ampacity at normal operating temperatures multiplied by any applicable reduction factors or ambient temperature and conductor bundling. So mathematically, ingani ang pagka-express niya na I ampacity is equal to the ampacity of conductor at a specific operating temperature is equal to the I normal, or the normal operating temperatures, multiplied by the FT, or katong temperature correction factor, or ang multiplied by FN, or the bundling correction factor. So proceeding with the example, determine the ampacity of a number 8 AWG copper conductor with THHN insulation that will be used in a 120 volts two-wire circuit in an environment with an average ambient air temperature of no greater than 86 degrees Fahrenheit or 30 degrees Celsius. No corrections must be made for temperature or more than 3 conductors in a raceway. So, since it is mentioned na no corrections must be made for temperature or more than 3 conductors in a raceway, we simply mag-assume lang ang ampacity in normal temperature, operating temperature niya is equal to the ampacity of katong sa kuan niya. Kanda a specific operating temperature katong time. So circuit conductors are sized according to the 140 degrees Fahrenheit for equipment rated 100 amps and less. So given na siya ang kuan na siya sa table after this na ang kaning 140 degrees Fahrenheit na corresponding na respective na ampacity niya, which is 40 amps. Naro siyang given na siya. So next example, determine the ampacity of a number 8 AWG copper conductor with THHN insulation that will be used in a 120 volts two-wire circuit in an industrial environment with an average ambient air temperature of no greater than 125 Fahrenheit or 51.7 degrees Celsius. 3 similar circuits will be carried in a conduit. Assume that a shared neutral is not used. The temperature correction factor for THHN isolation in an ambient temperature range of 123 degrees to 131 Fahrenheit is 0.067. Then, given na po siya sa table and sa nata sa solution. So magkuha ng kita ni direct substitution. So Ang ampacity, ampacity na normal temperature o katong ganiya. So since mag-base lang din to sa table, we'll have an total ampacity of 21.4 amps. So the ampacity of this conductor under this condition is 21.4 amps. Oh, yes, sir.
Napipotan na kanang pabalik sa previous slide.
Okay, sir.
Kanang asa gid kaning kuan kaning 0.67 o kaning 0.8 na mga correction factors.
Naara diri, sir. Kani. Maniguro. Actually, I'm not so sure, sir. Kay karon pag gid nako ni na kuanan kay gabi ay kaganiha lang siya bago lang gid siya nag-inform nga dili siya ka-report. So yeah,
Ay recording or simugot.
wala, sir, kay it was unexpected man jud, sir.
Baka pwede mo magbaylo na lang sa sunod nga meeting kay para at least maka-report na siya.
Oh, yes, sir. Ay, actually, hapit na ni mahuman ang mo ang report, sir.
Lagi sayang po simugot yun.
Lagi po siya nagbuhat ani nga slide, sir. It's just that wala siya ka-report karon kay bago lang gid siya nag-inform na dili ka-report, dili ka suffice iyang internet connection sa reporting.
O ba? Sige.
So proceeding with the conductor voltage drop requirement, this will be reported by Janelle Biniga.
So, good evening, everyone. I am Janelle Rose Binigas. I'll be discussing the conductor voltage drop requirement. So, in addition to capacity requirements, branch, circuits, and feeders should be analyzed for voltage drop because of the adverse effect it can have on performance and operating life of appliances and equipment. So, branch circuits are typically designed to ensure that voltage drop at full load does not exceed sa 3% from the panel board to the farthest outlet. Feeders are typically designed to ensure that the voltage drop at full load does not exceed at 2%. So the total voltage drop in the feeders and the branch circuit should not exceed at 5%. So this is the basic formula in determining the voltage drop. E drop is equal to 2 times L times R times I all over 1,000, where L is the one-way circuit length in feet or meters, and then R is the conductor resistance in ohms per 1,000 feet or ohms per 1,000 meters, and then the I is the circuit load or in amps. So let's have an example. Next slide, please.
So for the example of this topic, a number 8 copper conductor with THHN insulation has a one-way length of 200 feet. So it is carrying a load of 16 amps on a 120 volts two-wire circuit. Approximate the voltage drop and percentage of voltage drop in the circuit. So a number 8 AWG conductor has a resistance of 0.6410 ohms per 1,000 feet. So actually, ang kanisya is mag-serve siya as review or clarification na siya from our previous activities. Kinakatag na ni siya. So yeah, maminaw na lang. So given a formula is voltage drop is equals to 2L times R times I, which is ang ato ang current and ang R is resistance. So first is i-convert na to ang ato ang resistance kay since na may given na ang ato ang number 8 AWG conductor is a resistance of 0.6410 ohms per 1,000 feet. So multiply lang to nag-multiply tag 2 dire kay since ang ato ang given naman na length is one way. So dapat siya two way. So that's why nag-tag multiply tag 2 dire. So evaluating, we'll get a voltage drop of 4.1 volts. Then ang pagkuha sa percentage of voltage drop is ay divide lang nato to ang ato ang nakuha na voltage drop to the sa total na voltage multiply din nato og 100%. So evaluating again, we have 3.5%. So here you go. Voltage drop is excessive above 3%. So conductor size would need to be increased. So since 3.4% man siya, so kailangan gid siya i-increase ang size para dili somewhat kuan siya short or hit up.
So, approximation of the maximum one-way distance of a conductor. For single-phase circuits, mo na siya ang equation. For copper conductors, L is equal to E times voltage drop times circular mil divided by 21.6 I, and for aluminum conductors, L is equal to E times voltage drop times circular mils divided by 36 I. So, in metric computation, isubstitute lang na to ang constant nga 70.8 for aning 21.6 para sa aning copper conductors, and then sa aluminum conductors kaning 118 sa 36. And then for three-phase circuits, ano siyang equation, copper conductors, L is equal to E times voltage drop times circular mils divided by 18.77 times I, and then for aluminum conductors, L is equal to E times voltage drop times circular mils divided by 31.2 times I. And then in metric computation, substitute the constant for 61.3 and 18.7, and then sa aning aluminum conductors, kaning 102.2 para sa aning 31.2 para makuha na to ang length in meters. So let's have another example.
So for the example of getting the maximum distance of the conductor, we have approximate the maximum distance of number 10 AWAG conductors can carry a current of 200 amps on a 120 volts single phase current circuit. Use a maximum voltage drop of 3%. Number 10 AWG conductor has a cross-sectional area of 10,380 C mils. So for the copper conductor, if copper made of copper ang conductor, we have this formula. So actually ang 21.6 here is the kanang resistance constant sa copper conductors. Whereas ang kaning 36 diri sa aluminum conductors is most na ang resistance constant sa aluminum conductors. So moving on, since given naman nga to ang mga required na mga values, so mag-direct substitution na lang ta. So ang quantity nato, ang voltage is given na 120 volts, and ang voltage drop nato is 3%, so convert nato siya into decimal, 0.03. So ang circular mils dahil niya is 10,380. So naragap mo diri. So evaluate nato na siya dira, we'll get a length of 86.5 feet. That if copper ang material sa atong conductors. So proceed sa aluminum. Dili na dahil more gyapon direct substitution sa mga given values. It's just that ang ato ang resistance constant is 36. So evaluating again, we'll get a 51.9 feet length. So next.
Determining the minimum conductor size in circular mils. So, kaning formula ani nila, giderive na nato ni siya sa atong pagkuha sa maximum one-way distance of a conductor. So for single phase circuits, mo ni siya ang equation for copper conductors, C mil is equal to 21.6 times I times L divided by E times voltage drop, and then for aluminum conductors, C mil is equal to 36 times I times L divided by E times voltage drop. So for three-phase circuits, mo ni siya ang equation. For copper conductors, C mil is equal to 18.7 times I times L divided by E times voltage drop, and then for aluminum conductors, C mil is equal to 31.2 times I times L divided by E times voltage drop. So let's have another example.
So for calculating the circular mils of a conductor or the conductor size, we have a set of conductors on a branch circuit serve a swimming pool pump motor rated at 20 amps. The pump is 250 feet from the 120 volts power source. Determine the required size in C-mil for copper and aluminum conductors at a maximum voltage drop of 3%. So yeah, since ang kaning formula is derivation lang ni siya from ato ang original na formula sa pag-determine sa maximum length of the conductor. So the same process, magkuhan lang yapon direct substitution and then evaluate. So for copper conductors in a given kaning nga condition, we'll get a 30,000 C mils, circular mils, or pwede na nato siya i-convert into KC mil, then i-divide lang nato siya 1,000, kaning 30,000. So 30 KC mil. So for the aluminum conductors, same process, direct substitution, then evaluate. Evaluating, we have 50,000 CMLs. If prefer na to nga KCML lang atong answer, divide lang siya 1,000, which is equivalent to 50 KCML. So, proceeding.
The table provides that the ampacity of common insulated conductors of different lengths for 120 volts single-phase circuits for no more than 3 conductors in a raceway, cable, or earth burial for ambient temperatures in order for the normal operating range. Values in italics were governed by voltage drop for the one-way distance provided based on the maximum 3% voltage drop. So the first table here is in feet ang one-way distance niya, and the second table is in metric units. So ano na siya for example, a number 8 AWG size, and then one-way distance niya is 200 feet. So ang ampacity niya is 9. And then kung sa aluminum po siya, 300 feet, and then number 8 AWG na conductor, ang ampacity niya is 6. So next.
Oh, yes, sir.
Kasi dili mo aware sa time ba, hapit na mo human ang, you know.
Oh, last na, sir. Last.
Sige, baliw ko. Last naman na.
So, in order to use the electricity in our home, so a proper wiring is required. So, an electrical wire is a single solid or twisted copper or aluminum conductor with or without any insulation. So, each wire used for electrical wiring is marked with information like wire gauge, ampacity, maximum voltage, and maximum temperature. But a general code is used to identify different types of conductor which are used in electrical wiring. Depending on the phase of the power supply, different colored wires are used for different voltages. So with the help of this kanang color codes of electrical wires, it can be easily kanang ma-identify. Tapos ani sa picture, kaning black wire is always used for hot wires, and it is common on standard household circuits. Kaning red is also kanang designate as hot wires, and then kaning white with red or black tape, hot wires gyapon na siya, and kaning white and gray is indicated as neutral wires. And then kaning green and bare copper also kanang sahay na siya kanang stripes na siya nga green and yellow man na siya for grounding, and kaning blue and yellow is sometimes is indicated as sometimes hot. So next. In large commercial and industrial facilities where several system voltages are available, aside sa kanang color coding, it is useful, good, and safe to mark or label conductors and equipment for identification. So identification markings typically kanang indicate system voltage and phase. So for example, kaning nga table, 120 volts, AC single phase 2 wire, and for color identification marking code niya kani siya grounded, neutral, color code niya is white, and then grounded neutral white with black stripe running entire length of insulation. Then example po niya sa uh, identification marking code kaning ungrounded conductor, which is ang color code niya is black with a marking of 120 volts single phase. Dayon kaning sa 120 or 240 volts AC single phase 3 wire, same as kaning sa grounding conductor, area na siya sa 120 volts AC single phase nga. Ang color code niya is green, green with one or more yellow stripes, green tape, or bare. So, kaning ungrounded conductor, uh, ang identification code or color code na niya is black and red. And ang marking niya is 240 or 120 volts first ay single phase A, and 100 240 or 120 volts single phase B. So next, the 208Y or 120 volts AC, grounded neutral, same as white, and kaning sa kuan niya po, same ra gyapon siya sa grounding conductor kay commonly used man ang green with one or more yellow stripes, green tape, or bare copper conductor. So sa phase X, ang mga grounded conductor kaning phase Y pod og phase Z kay ang color code nila is black, red, and blue, and with markings sa end sila nga X, Y, and Z. Sa 480 Y and 277 volts AC, three-phase four wires, ang grounded neutral is for the first only neutral in raceway, box, or auxiliary gutter, or other types of enclosure. Same as the phase X ungrounded conductor Y and Z, nasa line mark I mean ang color code nila is brown, orange, and yellow, and nasa line marking nga sa last nga X, Y, and Z. Next is the 240 delta or 120 volts AC three-phase three wire. So for grounding conductor, green with one or more yellow stripes, or green tape, or bare per conductor. Same phase X, Y, and Z ungrounded conductor, black na siya pero ang lahi sila og mga markings. Sa end is X, Y, and Z. And then the last one is the 480 delta V volts AC three-phase three wire. Grounding conductor is green with one or more yellow strip, or green tape, or bare copper conductor. So phase X, Y, and Z and grounded conductor, color code nila is brown, orange, and yellow. And nasilay ka ng X, Y, and Z sa last nila nga marking. So that would be all. Thank you.
And that's all for our group, sir. Thank you everyone for listening.
Thank you po sa inyong report po, Kirby. Mayo po. Unique po ang style sa inyong presentation. Naipakilat-kilat.
Thank you, sir.
Sige ni. Palayo sa ko share sa palayo ko hatag sa share screen sa ako. Dili lang nga ako i-open. Anto. So na ko ihatag sa inyo ang take home nga skit work. So, by the way since nauman naman si Group 4, no? So, palihog ko prepare sa inyong report next week, Group 6 and Group 1. Kay main nang sa iyo tamahuman para bakante na mo sa kuan 1 week before midterm. Naman to ha. Tara. By the way, nakigisan nga katong gipantanan na kaganina nimo Kirby ba? Nagtaratana mo ko sa mga electrical code manggod sa PEC. Na dito akong ang answer sa akong pangutana.
Yes,
So,
sir.
talaan lang dito.
Wala kay
No,
pagkakuan
dilo.
na to, sir. Kay bago rin siya nag-ingon manggod kay wala daw ang internet sa ila.
Nakuan lang sad ko, tingala lang kung anong 0.67, anong dili 0.76 ang gipili. Mo lang to galibog lang kung gamay ba. Sige lang kay at least kabalo ta nga asa gikan ang source ato. So karon nako ipa-take home or rather ipa-submit nako ni sa inyo next week mga March 30, 6 PM deadline ani. So simple lang ni. So nako 5 ka questions no. So about aning mga questions and mention naman ni sa mga reporters and kanilang number 4 and 5, I think na mentioning 4 kanina. Ang kanina lang 5, palihog na lang kog research about aning riser diagram. So kaning riser diagram, typically, ang iyahang diagram consists sa mga service entrance equipment like atong conduit, conductor, mga metro ninyo sa kuryente, then padulong dahil sa inyohang main panel board or plangka. Then, kung napagid mo yung mga sub-panel board, so kutob dito. So, palihog ko picture sa actual na equipment na inyong gibutang sa inyong drawing. So, ang example guys, sa panel board ninyo or plangka, i-open lang na siya tapos picture apil ang mga makita na mga breaker or fuse. And hopefully, mabutang ninyo ang mga ratings pod. So, dagan mag-example sa internet aning riser diagram. So, pwede ra mo maka-search yun ana. So again ha, follow lang sa instructions, handwritten ni siya. Then i-follow ang file name, then i-submit ni siya sa U-Step on March 30, 6 PM. Okay, so napabatay questions?
Wala na, sir.
Sige, so kung wala na, pwede na siguro ta mag-class dismiss. So palihog ko group 6 and 1 ha. Prepare para next week sa reports. Okay, so thank you sa pag-attend sa inyong klase karong gabi and congrats sa mga reporters for tonight. So, pabusog na mo sa inyong panihapon ron and good night.
Thank you, sir. Bye, sir.
Thank you, sir. Bye, sir.
Thank you, sir. God
Thank you,
bless.
sir.
Thank you, sir. Good night, sir.
Good night.
Thank you, sir.